Something new in SOLIDWORKS Flow simulation for 2016 is support for equidistant mesh control. The way this works is that you're able to specify layers away from the geometry. Whether using solids or surfaces, you define the mesh variation through these areas to give more precise control in the areas of interest. In this instance, for example, for the aerofoil shape we can define shell offsets at different distances and also specify how many layers of refinement occur over those shell regions. For example, with this profile, if we specify only one layer and at 10 mm, you can see the profile along with how it's initially meshed. Then we increase that to 2 layers of refinement and then to 3 and 4. So you can see we actually have very precise control over the mesh variation and the subdivision that occurs. So it's easy to see how the mesh gets subdivided through the elements. Similarly, if we add multiple shells, we get more flexibility in controlling the mesh, especially when you have 3 or 4 layers. So we can control the uniformity between these shells. And of course, if we go up to 3, we see the same trend where we get much more control exactly where we want it. So let's take a look at this model to show how that works. One other thing you'll notice in 2016 is that now mesh controls are all within the Property Manager and are easy to interact with. Here we have our local mesh settings, and all we have to do is enable the equidistant refinement, where again we specify the number of cells we want and then how many layers between the shells, and then specify the layer values. This then creates the detailed results we're looking for. When we look at the results in this instance, you can see we're capturing good detail in the areas of interest, such as the high pressure areas and low pressure areas around these airfoils, which was a lot easier to set up than just doing a global mesh refinement. Also, you can create dummy bodies to specify mesh refinement in areas of interest as well. We can see flow details such as the velocity and in particular the recirculation at the back of the aerofoil. Equidistant mesh control is a very powerful tool for identifying characteristics of our models and making sure we are getting accurate results in areas of interest. Another feature in 2016 is the support for result symmetry. In this instance, for example, we have flow through a globe valve, and if we take a look at our computational domain, you can see that we've set up a symmetric plane through half of the geometry. So what we can do in section plots is manipulate the definition to mirror results on the symmetric side, giving us better insight into what's happening in that location. We can obviously drag this through the geometry and see the full model display. Similarly, with surface plots, we can also mirror the results to give us visualizations through the entire geometry. So again, a nice way that you can simplify your model for efficient computation, but still visualize the full results, just like we can in SOLIDWORKS simulation. SOLIDWORKS Flow simulation in 2016 has the added benefit of faster transient analysis capabilities. In the past, you had very little control over how many iterations it took to perform a transient analysis. New in 2016 is the ability now to control how many nested iterations occur during a transient analysis. By controlling the number of iterations, you can take larger time steps, obviously solving in a faster time frame. This can be quite substantial, in the order of 50 to 100 times larger time steps than what was previously available. So you can really focus on the level of detail you're interested in, not just in the solver stability. In this model, we're looking at the dissipation over time of a concentration of methane gas through the ventilation system to see how effectively it works. To compare performance, we can take a look at the solution time for all of the 3 different studies. The first study is using the default settings of the solver. We can see it took 1300 seconds roughly to finish. With the nested iteration control set to a maximum of 25, that comes down to 970 seconds, or a 26% time reduction. With the nested iteration maximum set to 12, this further reduces to 534 seconds, or a 59% reduction. So a substantial saving for the solution time, which is very beneficial for making sure we can quickly evaluate results and ensure the product performance meets our requirements. So some great benefits for time varying analysis in 2016.